Assalamu alaikum. This is a demonstration for the fourth experiment in the ME452 course. So the experiment title is an evaluation of a magnetic flow meter. So in this experiment we'll use the process variable measurement trainer, which is this setup. So the setup is mainly consists of two main tanks. So we have the lower tank and the upper tank. So in the lower tank we have thermometer to measure the temperature of the water inside this tank. We have an electric heater to heat up the water, and also we have a pump here to pump the water from the lower tank to the upper tank. So in the upper tank we have a pressure transducer to measure the pressure inside this tank. We also have three temperature measuring devices. We have thermistor RTD and thermocouple, and also we have a capacitive level meter to measure the level of the water inside the tank. So as we said, the water will be pumped from the lower tank to the upper tank using this pump through this line. And then the water will return back from the upper tank to the lower tank through this line. So in this line we have two flow meters. This one is the magnetic flow meter, the one that we will evaluate in this experiment. And we have also a paddle flow meter. We have this valve to control the flow rate in this line. We also have a scale here in the upper water tank to measure the level of the water manually. Here we have the main power switch of the setup. Also we have different data acquisition cards for the temperature, level, flow rate, and the pump, and so on. So in this experiment, in order to control the heater, pump, and valve, we'll use the LabVIEW software. So we'll start by pumping the water from the lower tank to the upper tank, this tank, until this tank is filled to a specific level. So we'll use the 20 centimeter as the reference. So it should start from the same level for all of the readings. So for each reading we need to start from the same level. Then we will keep the valve fully open, then measure the flow rate using the magnetic flow meter. So we'll acquire the data using the computer, the LabVIEW software, and at the same time we need to record the time needed for the water level in this tank to be dropped by 2 centimeters. Then from the recorded time we have the area of the tank, and we have the value of delta H, which will be 2 centimeters. So we can calculate the flow rate. So this will be the reference flow rate, which is the calculated one, and we have the measured flow rate using the magnetic flow meter, which will be acquired using the computer. In this experiment we will use this software, which is the process variable measurement trainer software. But first we need to connect the experimental setup to the computer using this cable. Now the setup is connected to the computer. Just open the software. So before opening the software I need to turn on the main power switch. So the same as the temperature measurement trainer, you can change the information of the user, or you can just click on the process variable experiment. So you have different experiments. You have flow experiment, you have pressure, level, and temperature. In this case we need to measure the flow rate. So I'll select flow measurement. So you see you have the layout of the same setup. You have the lower tank, the upper tank, you have the pump, the heater, the valve, and this one is the magnetic flow meter and the paddle flow meter. In this window you have two flow meters. This one is the paddle flow meter and this one is the magnetic flow meter. Now to run the pump, I just need to press here in the pump, and as you can see now the upper tank is filling. And it is discharging at the same time because the valve in the back line is fully open. So in this experiment I'll take different readings for different valve opening. You see that you have in this window you have the valve opening, it's 100% open, and this feedback is almost zero. This one shows the response of the valve. So when this one is 100%, this one should be 0. If I change this one to be 90, the feedback should be 10%. If this one is 80, this one should be 20%, and so on. Now I'll take the first reading, which will be for the 100% valve opening. I will stop the pump. Now the water level is at 16. I will start recording the time. Until the water level in the upper tank is at 14 centimeters. Now the time is 24 seconds. This one is 100% and this one is almost 0. I just need to press hold value over here. You see that you have the flow rate, which is measured by the magnetic flow meter over here, and you have the value in this table. So you have two different outputs. This one is a flow as liter per second. It also gives the output as a current in milliampere. So you have two outputs for the flow rate, flow in liter per second and a current in milliampere. So to take the second reading, I will open the pump again, fill the upper tank, but in this case I need to change the valve opening to be 95% and wait until the feedback is showing around 5%. Now it is around 5. I'll stop the pump and start recording the time, and make sure that you start from the same level, which is 16 centimeters. So for the second one I will just press hold value. So you'll have the second reading. Again you have two outputs, then you need to record the time again. Now I have repeated the experiment for different valve opening. As you can see in this table I have 5 readings. So I have changed the valve opening from 80% to 100%. So I have 5 different readings for the flow rate, and I have 5 readings for the time, and from the time I can calculate the flow rate, which will be the reference flow rate. Now when I finish the readings, I just need to press the save button. You see that you have this file over here. In this file you have all of your readings, which are 5 readings, 5 flow rates, and you have the output current. So I will upload this file with the time readings. Then you need to calculate the flow rate from the time using the equation given in the manual. And then you need to follow the manual to complete all the requirements. Thank you.